Hello everyone! By the end of this video, you will be able to describe the different components of an industrial electrolyzer and the role played on the overall system. We will start by seeing the components of an electrolyzer system, then we will focus on the balance of plants and its functions, and finally, present the different stages of an electrolyzer design. In order to increase the surface area without having to design cells of several square meters, single cells are stacked up to form a stack. The cells are in an electrical series circuit, but are supplied with water in parallel. To further increase the power, the electrolyzer system can contain several stacks. To supply the stack, a balance of plant, BOP, completes the system. The balance of plants allows the electrolyzer to meet all the conditions necessary for the stack to function properly in terms of water supply, gas purification, and temperature control. These parameters, therefore, need to be adapted to each different electrolysis technology. Here we have a simplified diagram of electrolyzer with a balance of plants. We can recognize the electrolyzer stack in black and the 5 different steps of the process: water purification, water and electrolyte recirculation, heat exchange, hydrogen and oxygen purification, and power supply. Depending on the technology used, this step will differ. Low temperature technologies require water with high level of purity. The water needs to be deionized. In a high temperature electrolyzer, the water not only has to be deionized, but vaporized too. The recirculation stage is also a stage where pure water is mixed with potash in alkaline electrolyzers. The heat exchange stage is particularly important at high temperature, and also operating temperature of the electrolyzer to be better controlled. An independent stack temperature control system can be added. Depending on the technology chosen, the composition of the output gases can be quite different. For example, water will be present in large quantities in both gases of an alkaline electrolyzer. In a PEM electrolyzer, it will present mainly with oxygen, but also in smaller quantities in the hydrogen. It will be exclusively in the hydrogen in high temperature electrolyzer, SOEC. Similarly, gases can cross over the membrane or separator, and as a result, some oxygen can end up in hydrogen flow, the crossover effect. Therefore, the hydrogen needs to be purified. In other words, the oxygen and water removed. A demister is used to separate the liquid electrolyte for an alkaline electrolysis. A deoxo, a catalytic system, is used to recombine oxygen with hydrogen to form water. That is then dried out to obtain high quality hydrogen. Please note that the oxygen is not always purified, as it is not always valued in a downstream process. Finally, the power supply must allow the electrolyzer to be supplied with a continuous current, which may have a more or less important dynamic variation depending on the electrolyzer. This stage is often composed of one or more AC-DC or DC-DC converters and rectifiers. The balance of plant must be optimized to maximize the energy efficiency of the whole system according to the quantity and quality of hydrogen that needs to be produced. Now that we have detailed the different components of the balance of plant, we can move on to see how the electrolyzer and the system are designed. Regardless of the technology chosen, the sizing of an electrolyzer follows 5 main steps. Firstly, the hydrogen requirements are defined. This then defines the electrolyzer surface area needed to produce the required amount of hydrogen. This area will depend on the technology chosen. It is systematically oversized to take into account the aging and loss of performance during the life of the electrolyzer, which is generally 20 years. This surface area is used to define the number of cells required and then the number of stacks needed to house these cells. These 2 parameters will most often be imposed by the manufacturers. They have made a compromise between the mechanical strength of the cell and the stacks, the possibility of supplying all the cells in an homogeneous way, and the production constraints. The choice of connecting the stack in parallel or in series and the optimization of the balance of plant is based on the choice of stacks. To finish, please remember, electrolyzer system is a stack of single cells which needs a balance of plant in order to operate. Each electrolyzer technology, alkaline, PEM and high temperature requires a suitable balance of plants that supplies the electrolyzers with pure water and purifies at the end the output gases. It must be optimized to minimize electrical losses and maximize water recirculation. The electrolyzer is sized according to the quantity of hydrogen to be produced, which imposes a surface that must be divided into cells distributed in stacks. These parameters depend directly on the technology chosen. Thanks for watching.